We talk. I do these sessions so that you are aware of what your children are doing and how you can help them. I want to start off very quickly with a couple of my big beliefs. You have to enjoy math. And I'm going to tell you right now, if you don't quite enjoy math, it is worth faking it for your child. And as you fake it, and you start having those discussions, and you start learning with your child, you are actually going to start enjoying math. Especially at the second grade level. I mean, I was just doing rates, ratios, and proportional thinking. That one was like, so please, the best thing you can do is make sure that the math is enjoyable. Second grade has changed their homework policy. You're getting more choice. There are some extra things being sent home also for extension that's starting up next week. So this should be a good time. The second thing, and I'm going to be really just brutally honest, and this is more of a Western thing. Women especially, you can't say, oh, I'm bad at math, I'm bad at math. There is no such thing as a bad math gene. We have mapped the brain. There is nothing that is genetic saying you're bad at it. We can't keep perpetuating that myth, and it is a myth. So, women, I am so glad to see you here today. I'm so glad that you're not saying, go talk to your father, he's the engineer. Okay. Good. You know what, I'm going to be honest, well, it does tend to be a North American, Western Europe issue. And my third thing is, your teachers are sending you home lots of information. I know you get a lot of emails, but if you read your teacher's emails, you know what to talk to your kids about. Because the death of a conversation, how was school today? Fine. That's a real short conversation. As opposed to, oh, I think your teacher said you were doing something with place value today. What did you do? You've given them a jump-off place. And that's what teachers do all the time. We scaffold. We give them a step or a trick, or it's not a trick, but we give them an opportunity to know where to start talking. So if you can ask that type of specific question, it helps. Now, I'm not daily, I know it is what it is. So your teacher sent home weekly emails. They also send home, once a unit, a colored strategy letter that tells you about the strategies that you're doing. The reason it's sent home in paper is so that you have it available when your child is asking you questions, or you're doing homework, or you're looking over, or you don't understand something. We know that if you had to stop and go find your computer first, hope that it's plugged in, and then find the email that had the attachment, we've just lost all the continuity. That's why we send it home in paper. We hope it's put in a safe place near where you tend to talk with your child. In my house, that would be on the refrigerator, where I know where it is, I can see it. So you'll get one, and I can't tell you exactly when they come, because our units come in different chunks. This is second grade. You started off with 2 really, really quick short units. They are now entering their first really meaty unit, and it's on place value. So that's what we're going to look at today. One of our bigger changes, or ways that we've progressed from last year, is we are now doing number talks. Sherry Parrish came last year. I don't know how many of you were able to come to her talk. She was amazing. But I want to do a number talk with you so you can see what's going on with your children. Number talks are designed to help kids with with just their belief in themselves that they can solve things. It is meant to be mental. So it's kind of like developing strategies so they can figure out how to add, subtract, multiply, divide, figure these things out without reaching for a calculator. I'm sure I, by far, am the oldest one in the room. I was taught there's one way to do it. You better grab your pencil, you better hope there's an eraser on it, and you need to have a piece of paper in front of you. We were shortchanged. We got a calculator in our head, and it works really well if we use it and we practice it. So we're going to do a 10-minute number talk. It's going to be faster. I'm going to jump what we do because you're not second graders. But do remember, I'm doing this kind of in the lens of a second grade student. I'm not going to be super, with the kids, we do a lot of things to get them to keep thinking and come up with multiple answers. I'm going to ask you to, but I'm not going to go into great detail. So first of all, this is mental. If you've got a pencil in your hand, you won't need it. So when I give you the question, I want you to think, what's the answer and how can you prove it to me? And when you have one idea of how can you prove it to me, can you think of it another way? What is the answer and how can you justify it? With the kids, we would be doing, oh, I know one way. I know a second way. Really clever kids, we give them, once they get past 5, they get to do the math fan. And that's to honor the other thinking that's going on, because we all know that Susie's the smartest one in the class, and as soon as her hand goes up, I can stop thinking until she's going to answer it. We don't want that. We want everybody thinking. Okay, 8 plus 7. What is the answer? Anybody think it's something different? We would collect all the answers, and in second grade, we actually would get several answers. But that's fine, we don't always. Who can prove to me that it's 15? How can you explain to me why it's 15? Yeah?
We can split the 8 up into 5 and 3, and then you have your 10th by doing the 7 and the 3. And then you have your 10th plus 5, it's 15.
Okay, do you agree? Did she prove it was 15?
Yeah.
Okay, another way of proving it. Yeah.
If you know your doubles, you know 8 plus 8 is 16. And then you know 8 plus 7 is 1 less, it's 15. Or if you know 7 plus 7 is 14, 8 plus 7 must be 1 more, so it's 15.
All right, whoa. Okay, go back to the double. 16,
Yes.
I know that it's 16 minus 1, and that would equal 15 using doubles.
Yeah.
Okay, another way of doing it.
It was the 7. The double of 7 is 14, 1 more.
Right.
Same thing.
Right, okay.
My number bond.
Okay, what would my number bonds look like?
7 is 2 and 5, so 8 plus 2 would be 10, and you have the 5 left. 8 plus 7.
Okay. Do we all agree that it's 15? This is a warm-up. This is for you to continue looking at if you need the support. Can you see that?
Not really. What does
Shadows.
it say?
So what does 80 plus 70 equal? Okay. How can we prove it's 80 plus 70 equals 150?
Drop the zeros.
What do you mean by drop the zeros?
Well, then you do the, like you double the 8s. So you 16 minus 1, then add the zeros.
Okay, so when you say drop the zeros, I think in math terms, we're going to start talking about it as 8 tens
Oh, no.
plus 7 tens. And this is where we start getting the math vocabulary and the explanation. Because there was a kid in the class that when you just said drop the zeros, they're like, oh, why can I do that? So I know what you mean. I know that you understand it, but I'm going to help that child, another child in the class who's listening, who has no idea where I can drop. So now I have 8 tens plus 7 tens. You can explain to it 8 plus 8, the doubles, or you can also say, well, I already know over here. And we talk about mathematicians build on their knowledge all the time. We don't always go back to 0 to start to explain something. So you might give me the whole explanation. Or you might say, oh, we proved it over there. Now we're rolling. We're not doing this with second graders, but again, you're not second graders. So my last question. You're so bright. know that 80 plus 70 equals 150. I have a 1 plus 3 equals 4, and I know that 150 plus 4 is 150. When we talk about kids having number sense, we are talking about this flexibility. They can see numbers, they can take them apart to make it efficient for them to do it in their head. And the reason I chose to do this with you is being able to see numbers in many different ways is what place value is about. So that's why this unit is so important. Okay. By now, you've noticed there's a bunch of things on your table. Those are straws. Not exactly a high-tech math manipulative, but they work really well. I want to know how many straws there are in the room. Please work with your table mates. How many straws are in the room? And how can you prove it? Before you get started, do you have any questions for me? Okay, I was asked, do each of the tables have the same amount of straws? No way was I going to count out this many. Did I estimate and try to give I approximated on piles? Okay, I'm going to treat you like kids right now. Would you please put your hands up by your shoulders? Because you won't listen to me if I let you keep working. I promise, when hands are up in my classroom, it means it's a 10-second question. I would just like some estimates. You filled with your table a little bit. How many tables are there? Well, shouldn't even give that. So how many do you think might be in the room? Okay, so I got a 2,000. Pardon me? Okay, so we're going to just accept. There's possibly 2,000. But I want to know exactly how many there are. So please keep going. You're already using them, I'll give you some more. Very fancy math board for yeah, that would make me more popular. I think this is one of the times I got even, and the people sitting in the back got more than this. You like it? Yeah, you have plenty of rubber bands. Okay. Vicky, would you like some rubber bands? More rubber bands? Yeah, may I?
We do it
There's a way. What's the easy way? I have So you want a
one part is taken. We actually have 3 left. So what?
Yes. I would like to know how many straws are at your table, and I want to know how you're going to prove it to me without counting every single straw. Let's start in the back table. How many did you guys have?
155.
And how do you know it's 155?
We counted.
And so you counted by 1, you went 1, 2, 3. Okay. What did you guys get?
We got 223 because they gave us 2.
Wasn't an even number.
Okay, so how do you know it's 223?
We split them up into 250s and some 10s, and then we got 3 left.
Okay. And are you really sure
Yes.
there's 50 in each one of those?
Yes.
No,
Why?
we bundled them into tens first, then we collated them into hundreds, and then we had the leftover of the 23.
So you guys, if you lose recess, if they're wrong, which story are you going to believe? Or which story would you trust more? A bundle of 50, or we bundled them into 10s and then put 5 together? Yeah. Okay, I'm not going to do this for every single table. Your kids probably just did this very exercise in class with them, if not yesterday or the day before, maybe today or tomorrow. This exercise goes about showing how our number system is set up. It is a base 10 system, and that you can be very secure in your ones, and then you can put 10s together, and then you can put 10 bundles together, and it equals 100. At second grade, knowing that 10 10s equals 100 is a very important fact. We can tell them all we want. You're part of ASD. We believe in the kids building their own knowledge. They just built that knowledge. Every single child is going to remember that 10 10s equals 100. And that becomes really important when we start adding. And what happens when I take this 100 apart? What do I have? I have 10 10s. Think about the subtraction that we do. When we have to regroup because of numbers, that your children have built 10 10s and made 100. They've taken that 100 and they've taken it apart. They know it still equals 10 10s. At second grade, there are children that have to do this multiple times to really believe it. Other kids, I get it. They look at it, they see it, they know it, and we move on. But this building of knowledge is very important at this point. So they're now understanding that this equals 100 and it equals 10 10s. Is there another one? So how much does this equal? 200. And what else does it equal? Or how else could you describe it? It still equals 200. 20 10s. What's another way you could describe it? 200 ones. What's another way you can describe it? 450s. Probably you're going to get that answer, but a lot of kids aren't going to see that. Could it be 15 10s and 50 ones? This is the flexible thinking that we start wanting the kids to have, that most of us were not taught to do. It makes sense, but we're not used to asking our brain to do that. And this is where our number sense comes from, is that flexibility and that being able to change things around. We're done with these. I don't have baggies, just put them aside. You don't have to take them apart. I would prefer that you don't, because otherwise I just drop, I don't care one way or the other, but I don't need them back. Let's look at the packet that you've got. The first page, you can contact me here. I guarantee to get back to you within about 48 hours. I don't guarantee you'll actually have the answer, but I'll at least get back to you and acknowledge that something's going on. It's usually in the same day, but I get told all sorts of different ways. I have made a link for parents that you can go to. The reason this is being videotaped is we're going to put the videotape of this session up on this page. ASD, just beware, there's a medical term that's called ASD, so if you just go looking for it, if you put that whole thing in there, it should pop up pretty easily. The site is called Live Finders, and so that may be it. It's a really ugly URL, because they are. But up there, you will find the videotapes of this. It will have the worksheet. It will have the worksheet and the answers, because we're not going to get to every single problem today, and I don't design that way. It also should have the parent letters, but it's also a website, so the stuff is up there from last year. I don't want to take it down until we roll into this year. Very little is changing, but we tweak things. We want things improved. I don't do this for every single unit. We do these for the major units of the year. So that's where you can get it. And if you can't get into it, email me, because then that way I can send you a live link. Okay. The next page. Talk about vocabulary. Kids being able to justify and share their answers needs to be working with a common vocabulary. We don't test kids on it, but we use it. And I know many 3-year-olds who can say Tyrannosaurus Rex and Triceratops. They can use the mathematician. We like to. We talk to them about thinking like a mathematician, talking like a mathematician, and they turn it on and they go for it. So, just quickly, compose and decompose. Compose, we put things together. Decompose, we take them apart. Number or numeral. We care, a number is the usual way of writing it. When we talk about numbers, that's your general thought. The place values chart, they're going to use a lot this time. So it can be hundreds, tens, ones. So we don't write 80 tens in the tens place, because we were saying there are 80 tens. We're flexible with it as they're learning. If kids really want to write down 80, and for some kids that's actually a step forward, that they're seeing that, the best thing that we then do for them is that they don't write tens. You're using an organizational chart. That's great. You understand that it's 80. That's great, but you don't have 80 tens. That's splitting hair at this point, but just to let you know. Unit form. May seem a little odd, but actually we use them a lot. This is where I used 15 tens and 50 ones. That's unit form. Most of these are very common sense. It's not labels for you to remember. Expanded form is how we can write a number out based on place value. Word form is a little bit obvious. Number bond. Number bonds, I'm showing it to you broken out by place value. That's my choice because we're using place value for this unit, but you can break a number apart any way you want. But it is a part-whole relationship, or a part-whole relationship, that these numbers should always equal this. I would say in general, most number bonds, it's at the top with the 3 beside, but it can be on the left with the 3 parts on the right. It's the relationship that's important, not the directionality. And we will try to get kids to actually use both, to not get them stuck. Again, it's that flexible idea of understanding what a number is and what its value is. They will be going into and explaining less than, greater than, and equal to. Equal is actually a very complex idea for most kids. And you change it to same as, They're like, oh, that's all you're asking? So we use that language a lot. We do say equal. We do tell kids that we're interchanging the words. But we talk about just having lots of words. The last two, benchmark and or friendly number, those are the same things, but this is this idea, I think earlier somebody did it and I didn't label it, but we got to something equal to 10, and then we can add on the rest. The patterns of 10s are very easy for us. You know, most of us, it's in our money system, it's in our number system. They're just easy because we could drop the zeros or we know that it's 110. In second grade, 5s still might be needed for some kids, but we can go to 10s. When you go to 10s, you understand 100s. When you go from 100s, you go to 1000s. So we're implicitly or explicitly teaching the structure of our numbers. Last, the knock on conceptual math is, but when do they get to the point where they can really do it? I promise you, we want your child adding and subtracting easily and fluently. There's a time when they do that. They learn that, or they practice that after they understand it conceptually. But we start talking about what is the efficient way of doing it. And that's kind of how we start trundling kids towards the most efficient way of doing it. And I would argue that for most of us, 10s and 100s is more efficient than 50s or 25s. I'm American. 25s are very easy for Americans because we have quarters. I moved to Kuwait and honestly for 2 days didn't understand that their coin was 20. I'm like, what? And you know, of course I can do 520s equals 100, but I was so used to quarters. So we all have our references that we have. But our place value system really lends us to 10s, 100s, that. So we do talk about getting to the most efficient way. Nobody brought up on 8 plus 7 that it's 8, 9, 10, 11, 12, 13, 14, 15. If that is the only way a child can get to 15, that is the most efficient way for that child that day. Because efficiency does mean getting the correct answer. And if they don't know doubles, if they don't know how to break it apart, I know I need to be working with that child a lot, but that is their efficient way. So we don't make judgments on efficiency. We move kids moving along, but your efficient strategy and your efficient strategy may be two very different things. But there is a difference of, but I like counting on my fingers. And that's where we as teachers get going on being efficient. Well, you know, it's easy to get lost. What are you going to do when the numbers get bigger? And it works. They watch the table dates around them. They listen to other kids. They start understanding it. They do move towards the more efficient way. And I would say that by 5th and 6th grade, that's when we really start using calculators. Because most of us do not divide a 6-digit number by a 3-digit number on paper. We pull out the calculator. So right now, their calculators in their head, we do move them towards that, but we want to make sure they understand it first. Okay, so let's move on and let you do some more work. Okay, it states I want to count from 100 to 133. How do I explain what is happening? Start with a bundle of 100. So if I'm starting with a bundle of 100, and right now, a lot of kids are going to be drawing this because they are drawing exactly what's in front of them with straws. So I have a bundle of 100. Add the units you use to count from 100 to 133 and draw a picture. So I have 100. I need to get to 133. What is the next thing I could put in this picture? I could do a 10. And I would have 110. And I think I heard do 3 10s. And then I'm going to add the 3 1s. That's what we're getting them to do. Adding up, starting in the middle of the plate in any number, as opposed to from 1 or from 0. Can it be done a different way? I guarantee we love these unique kids. Is it equally as accurate? I wouldn't even say anything about efficiency. This child is probably going to switch to this when they keep seeing it over and over from table mates because it's just not as common. But I don't care whether they switch or not as long as they think they're accurate with it. How many of you have older children in second grade? Okay. We do switch over to base 10 blocks. They tend to be blue, but they're hard. They can't be broken apart. And the pictures would just start being 100, 30, 3. We moved to that, but that's actually a level more sophisticated. Right now, they've got the straws in front of them, they need them, and they're just drawing pictures of it.
Have they done it last year?
Yep,
Yeah.
yep,
For the dogs?
yep. Yeah, and every time we take the math to a new level, we make sure we go back to concrete things, and because it's so important that they can take it apart, we're using something they can literally take apart. Yes?
So, for someone that we're teaching the other way, how do they not get confused where the 10s are now, the ones are now lines, where the 10s used to be lines? Because that confused me, because I'm trying to learn this way.
Okay, they've got the straws sitting right in front of them as they're doing this. And that's why, and it's sometimes we just have to say we're doing this, I chat with it, we're doing this for a reason. I wouldn't talk about it now, but when I move back to the base 10 blocks, I talk about where's the confusing part here.
Okay, because again, you're looking at the squares, and if you haven't drawn it properly like a child, and you've been sort of lazy, how do you know that's a 10 and not a 100? Because,
Yeah. But math is about accuracy.
yeah.
And some of it, these are the discussions we have all the time. There is nothing wrong. I'm going to be overjoyed with a kid who looks at it and does that wrong, and we can discuss it. Because when we can discuss it and we can verbalize it, we can all understand it. As opposed to just letting it go or marking it wrong on a paper. And for every child who brings up that confusion, there's 5 more equally confused kids who were too shy or not quite paying attention and who would miss that point. So this is kind of back to my very first thing. Mistakes aren't a problem. They're a place for learning. And they're really a good place for clarification. I'm not saying we want kids always making mistakes, but they're making mistakes when they're stepping out of their comfort zone and they're known. So actually, I'm going to take that back. We do want kids making mistakes. That means they're learning. It means they're trying new things. We want to make sure we deal with the mistakes.
Excuse me. Sorry, Kat.
Yes.
I might have just dozed off a little bit there. What was mentioned at the front was last year they were learning the squares, the strokes and the dots and the confusion from one year to the next. Pardon me. If they're actually doing this now, knowing that it's 100, the strokes are 10s and the dots are 3 at the ones, that's not a problem whilst they're doing the straws. It's something
No, if a child drew this
Yeah.
to answer this, I would be totally accepting
Yeah,
it.
okay, that's fine.
Yeah. You need to be real careful. I don't ever say anything's wrong that's actually accurate. And that's actually a mind shift for a lot of teachers because they kind of know the answer they want. 4th grade, talking about decimals, and they say 1 and 2/10. And their teachers will, in the English language, we don't say the and. It should be 1 in the most proper way. It's 1 and it's. Wait, how do I say that? I'm sorry, we don't say 152 and 2/10. We don't put the and between the hundreds and the 50s. But you know what? It's accurate. Grammatically, we may not like it. And we used to mark it wrong. Or if it was an oral thing, we'd say that's wrong. It's not, and that's something we have to step back. We might say, especially in English, that's not the way we say it. A mathematician would say it this way. But I've got to accept if it's right. And why am I being so picky about an and then we come into a multicultural school where in Spanish you would have the and. So we're trying to be kinder to each other about that. Yes?
We had an
an assessment sent home this week and it asked about modeling and if the child could model. Is this the definition of modeling? Like drawing a picture, is that?
This is going to get a really specific answer. This I would call communication and justification. Modeling is really specifically, I'm re-looking at this. Modeling is about showing that the kid understands the problem. It's when you take a word problem and put it into pictures. So yes, actually, this would. And it gets a little bit, it gets smudged as you go lower because the problems aren't as meaty and there's only so much you can do. So that a model lets me know the kid understood the problem. They could take it in a contextual story and put it into mathematics. They may not get the answer. On this particular one you do, but on a different problem. Actually, we're going to come to some later. I'll show you what the model is versus getting the answer.
Thank you.
They sometimes overlap, but not always. Yeah.
So model versus strategy?
Strategies are about getting an answer. So again, can I show you on this just isn't a good problem to talk about. And I'm looking at the time, so let's move on. The next one is the same idea. I don't think we need to do it. The third problem, I'd like you to take a minute and do it at your teams. This is the type of problems we ask the kids. Read, draw, and write. That's how you're explaining, communicating your answer. that goes through middle school. So I'm going to use it. So I know that there were 611 chapter books and 74 picture books, and I want to know what the total is. This would be a model representation of that problem. It's called a tape diagram. We're calling it a tape diagram. It's also called a bar model. It comes from Singapore math. So I then twist it and I call it a tape model and I call it a bar diagram. So it's the same thing. It's quite related to, it's a part whole representation. So this question could also be 611 and 74, and we're looking for that total.
Can it be used for subtraction as well, or only addition?
What do you think? This is the beauty. In many respects, we no longer have, I would say we don't really necessarily have subtraction problems. There are people who always add up. They're still finding, we call it now a missing addend. I was taught that it always had to be a subtraction problem, but it doesn't. There's multiple strategies of finding it. And that's what the bar diagram shows, tape diagram shows so well, is that you understand what's missing and that's what you're finding. You might do it through subtraction, I might do it by adding up. I still need my other strategies, because at this point I don't have an answer. I've just represented that I understand what I'm being asked. And this is where most kids get lost. The research shows at this age, they're going to grab both numbers and add them. By 5th grade, they're going to grab both numbers and multiply them. They disregard the story, they disregard the context, and they, in general, kids that are struggling or kids that are not paying a lot of attention, they don't even read it. They see two numbers and they just go. So that's why the modeling has become so important to us, is that understanding of the story. So now, the child knows what's missing, and in all likelihood, if they get here, now they need to go and they need to do the addition. They may struggle with the addition, they may not, but they've at least got a chance because they've proven to us they know the story. There's lots of ways kids can do this problem. We can do 600 plus 10 plus 1 plus 70 plus 4. Broke it apart by place value, added up the place values together. Well, I should have done that. I'm sorry, I just skipped. Your kids will get to this. They would be building it first. I'm sorry, that was me skipping. We'd have hundreds, tens, ones. I'd have 600s. I'm sorry, I would be drawing circles for this. I wouldn't be writing it yet. 600s, 110, and 1, plus 70, and 4. And then they can add them up. Oh, I'm just going to say flat out, in 2nd grade, they don't understand that. They can memorize how to do it, but if they get lost in that problem, they don't understand what that carrying of 1 means yet. We're going to build this with these chips. We're going to make them, this is, and we start with the simplest. This didn't have any regrouping. On the next one, we would make them take the 10/10s, move it over to the 100, and we physically do it. Then we draw it. Then they're ready to go on to that highest level, which is abstract, which is purely numbers. The standards say that is 4th grade.
My kids come from a different school, and they did that, and they're completely confused now. Their system is completely off.
Okay, and you know what? I love the way that you said they're confused now. We're going to keep working with them. They will. Now is an interesting, we use the term yet. They don't have it yet. We're not going to abandon them. And we feel, the research completely backs this up. If they take a step backwards and learn what all of this is doing, they're going to be able to see the connection to doing a column method. and for kids who have learned that, I'm going to accept that they do it, but I'm going to make them prove that they're correct and this is the proof. And then I'm going to ask them, the higher level kids, where's the connection? What do you see the same in both of these? And that's the important part. And when they can start taking them apart and comparing them to each other, then they're really going to understand it. And I will ask you as parents not to show them the column method. Once you know, I would say they're easy to memorize algorithms, none of us want to go back and learn the understanding for it, even though they'll be better off. That's like telling a kid, eat your broccoli because you're going to care when you're 85 and you're healthier. You know, they don't. I mean, that's human nature. I'm not going to blame it on kids. I teach teachers that kind of way. So we really want them to have that conceptual understanding first. So I'm going to kind of apologize because I jumped to this immediately. We would have had them build this story with these blocks. We would have had them put it on the place value map. We'd have then compared it. Now, this strategy works perfectly well. I would take it from a child and then I would ask, okay, so we've got two different strategies here. Did we get the same answers, which I didn't finish? How are they alike and how are they different? And the difference isn't as important. But when they can start comparing these two fairly different strategies, I don't know if that different, you can see they're broken out by place value, but when they can start seeing that, that's when they're ready to move on to the more abstract level.
When do they get to the numbers?
They'll be using numbers along with this fairly quickly. I mean, I'd probably be having the kids label. I mean, I would have this number 611 written here, and I would have 74 here, but I'm not putting it into the column method and having them do that. As I said, that's a 4th grade standard.
Fourth grade,
4th grade.
column.
Now, they've got older brothers and sisters, they've seen it, I take it from them, and in 3rd grade, we start doing this with note-taking, and really by 4th grade, they've already figured it out. Again, I accept it, but they've got to be able to explain it to me. And explaining is not, I carry a 1 over into the tens place, it's showing me what was proven. I got about 5 minutes.
Just one question. I mean, what do they have to write in the paper, in the assessments, for example, to get a right answer?
Because it's part of our standards say you will communicate and justify your answer.
Okay.
So we don't, addition, subtraction, multiplication, and division, doing the work, that's arithmetic.
Okay. So they have, sorry, just to clarify myself, I mean, from this, what do they have to put in the paper in order to explain what they are doing? Everything? Maybe I'm not clear.
Okay, so how much of this? There's 2 different strategies here.
Okay.
There are times when we will ask them to show 2 different strategies.
Okay.
On most assessments, you're going to get some that ask you to do 2 strategies. They're probably straightforward arithmetic.
Okay.
When we get to these type problems, 1 is going to be enough. So I would say, this is probably what I would have expected the kids to come up with. This number bond is a variation of the tape diagram, and this is a different strategy for adding than this.
Okay.
And there are multiple other strategies for adding.
And then the right is what? I have to actually write a sentence.
They have to write at the end, it's called ensuring that your answer is reasonable. We would expect, well, I call it an answer statement. I think most teachers are using that language. So this answer would end up being, what is the answer? What's it? 685. Yes, 685 books were sold. This has become more important than we realized. It's one of those things that makes the kids have to go back to the problem and are they really answering the question that was asked? Because a lot of times they're not. So it's back to our practice standards that say, can you prove here. It's going back to the problem. I did actually answer the right question. Okay. 5, 6, and 7, do you believe me? They're the same thing. We get into the regrouping. I can show you what regrouping would look like. Now, they're building it first. Then we're going to take 10. It's exactly 10. And I'm going to move it over here. I now have 10 tens. I'm going to take it and I'm going to move it over here. And I'm getting my answer. And you know, because you understand column method, that that's exactly what we're doing with numbers, but we're doing it with the pictures first. We're doing it with manipulatives first, then we're doing it with the pictures. And so now I have an answer of, that's 830 binders. In the cabinet or something, I don't know how many binders are there. There are. Yes?
Try the last one, 7, just for the fun of it.
Okay, let's do a tape diagram. Sam and his dad, can you see? Sam and his dad have 70 cupcakes. If they baked 100, how many cupcakes do they have left? We know the total was 100. And our question is, how many do they have left? So this is a good example. I can now count up to 100. I could go, I got 70. How do I want to do this? Let's do this. Plus 10 is 80. Plus 10 is 90. Plus 10 is 100. So they have 30 cupcakes left. Or, I had 100, I don't know why I keep doing that. I had 100 cupcakes. I sold 70. Let's do it by 10. So it's minus 90. If minus 10 is 90, you get the idea? 80, 70, 60, 50, 40, 30. My number line wasn't long enough. These are all minus 10s because that's what I need to do for my thinking. And I get down to 30 here. And this would have been 100 minus 70 equals 30. 70 plus 30 equals 100. And this, you have to know where to look for the answer. So kids are having to tell us, what is it that you found? I found that there were 30 cupcakes left. But this is one where it does, we no longer say it has to be a subtraction problem. Because if a child is adding up, we just undermined what they're thinking. They don't see it as a subtraction problem. They see it as it's called a missing additive. This number is missing, I need to find it. Questions about that? I promise you it goes slower for your kids. We do it with the manipulatives first. We draw what we're doing. And I just want you to look at the back page. The number 8, excuse me, is showing that they can recognize, that they can read a unit form and change it into a number. So 203 ones, 203 tens, 406 ones, and 604 tens. Now they may be, on an assessment, they may be asked to prove it so that we can see the picture of it. Because you'll notice, this is on purpose, it's 203 ones versus 203 tens. This is where they're going to make an error if they don't understand what's going on. And within this, in the place value, we do the greater than, less than, equal to, or same as. They've started that in first grade. We do want them to show us proof. Is 47 larger or smaller or the same as 147? No. So I've got 4, 1, 2, 3, 4, 5, 6, 7. Or I have 100, 1, 2, 3, 4, 5, 6, 7. You've just proven that 47 is less than 147. We used to just accept the sign. One, you can guess, there's only 3 of them, and honestly, equals is used very seldomly, and kids figure that out. Or they could understand it, and they just got the signs flipped. As a teacher, for me, that is a very different instruction. When I go to help that child, if they understood it and just don't understand the sign, we just have to figure out a way for them to remember what the signs mean. If they don't understand what's going on, that's a completely different lesson that I need to teach your child. So that's also why some of the explaining is coming up, is so we can find out where, very rarely are they usually have something that they understand. And now I know where to help them. Yeah. Yeah, you know, I can't tell you exactly that. If they're not given it, they've practiced it a lot in class. This is a way that you can show it. I can't picture the assessment. I don't have it memorized in my head. But this is how they'll be asked to do it in their classwork. At some point, there are other strategies. You could break the numbers and stuff apart, but they will definitely be taught this as one strategy. So I just use another one. Yeah, I think they're going to have to a number bond. They're going to have to show me why it breaks it apart. They better make it clear to me that they can see that the 100 is another one. I'm going to take a look. The very last page. I've given you websites for extension. Some of your kids are going to see this. They're going to understand it. I do believe they need to see it and they need to practice it a little bit, but I understand on the first or second go round they're hard to get it. So we do want to give you other areas to extend your child. Larger numbers doesn't really extend them. It doesn't actually, it's not more rigorous. So Math Playground is probably my favorite. And they got logic problems on there that are just spectacular. And that's really mathematics, is taking the arithmetic and doing something with it, or figuring out spatial things. These have been around for a while. The kids love Math Playground. The next 3, they're good. You can see they have different things like Math Art. The last one has an asterisk. I put it there because the new tech integrator, Jen, I'm sure I know her last name, came to me yesterday raving about it. I will be honest, I've asked for a demo. I have not played it. But this is from a techie person who said her own child loved it. So I'm giving it to you with the caveat that I'm sure it's excellent as much as I can be, but it comes highly, highly recommended. So if you're looking for things for your child to do, they got it. We don't need to beat them over the head with it. This would be a great way to extend it. I'm here for another 10, 15 minutes. If you need to get going, I understand, because we are at our time.